Hi, everyone. Just now, we were given an equation and we found the graph for that equation. We're now going to do the inverse problem. What do you think I mean by the inverse problem? I give you a graph and you give me an equation. Finding an equation for a transformed graph. Now, to be fair, in chapter 1, I'm only going to give you graphs that are that can be obtained from one of our basic graphs through rigid transformations. However, in chapter 4, that's going to change. In chapter 4, in trigonometry, we're going to look at non-rigid transformations like stretching and squeezing. But here in example 10, find an equation for the transformed basic graph below, where the transformations are all rigid. I'll give you 30 seconds. Start with which basic graph you'd start with, and then what transformations you would apply. Go. Here's another challenge. Another 30 seconds. Find another way of doing it. Go. Okay. I'm actually going to start with what's strategy 2 in my notes here. Well, first off, hey, what's the basic graph we want to start with? How about absolute value? So we're going to start with y equals the absolute value of x. Let's start there. Okay. And then what are a couple of things we could do? Well, we could, okay, now here's the thing. I'm starting with an upward opening V. How do I get a downward opening V shape? I could start with a reflection. Reflect about the x-axis. And the corresponding equation would be y equals the opposite of the absolute value of x. Multiply the right-hand side there by a -1. But wait, the corner point is currently at the origin. I need it to be at 0, -1. So let's lower this thing by 1 unit. And we should get this graph over here. Y equals the opposite of absolute x, all that, -1. And that should work. Let's verify this on Desmos. Y equals ABS for absolute value of x. Okay. Let's put a negative sign in front. Get the downward opening V, -1. And there you have it. All right, so that is that. So that's one way of doing it. A quick recap. Strategy 2, reflect, then drop. We go to y equals the opposite of absolute x, and we have y equals the opposite of absolute x -1. So that's one equation we can use for this graph. But there are other ways of writing the equation. There are different forms for the equation for this thing. Well, I'll pose this question. Now, remember, here we reflected about the x-axis and then dropped by 1 unit. if we were to switch the order here, would we get the same result? If we take the original graph, which was this up here, if we had taken this original Big Daddy graph up here, the absolute value graph, and if we had lowered it 1 unit and then reflected about the x-axis, will we get the same thing? Let's try it. If we lower it by 1 unit, we get y equals absolute x minus 1. Corner points at 0, negative 1, which is what we wanted at the end. But wait, if you try to reflect, if you try to multiply that entire right-hand side by a negative 1, uh-oh, this thing's too high. The y-intercept is at 0, 1, not at 0, negative 1. So this is wrong. It's not what we want. So the order can matter. The order can matter. We don't have commutativity here. The order can matter, especially if you're mixing up translations and reflections. Bear in mind, if you have a bunch of translations, you can apply them in any order. If you have a bunch of reflections, you can apply them in any order. If you have a bunch of rotations, you can apply them in any order. But if you start mixing types, you can get into trouble if you switch things or mix things up. All right. So what would be an appropriate way of doing it? Okay. What is one way that we can get the graph up here? What's a way of getting from the original Big Daddy absolute value of x graph to this transform graph over here? If we wanted to do a translation first and then a reflection, what would you do? You don't want to go down before you reflect. You want to go up before you reflect. It's that old saying, the taller they are, the harder they fall. Strategy 1, this is correct. This will work. Raise, then reflect. You actually want to add 1. Raise the v graph by 1 unit. So you have y equals absolute value of x plus 1. And then you reflect. You multiply all of the right-hand side, all of it, by negative 1. So notice I have grouping symbols here. I'll put that in red. You need the grouping symbols here. You're taking the opposite of all of that. And then you could distribute later on. So you could write an equation for this thing as y equals the opposite of absolute x plus 1. And what happens if you distribute the negative 1? You get y equals the opposite of absolute x minus 1. And hey, that's the same equation we got as in strategy 2. Because we have equivalent equations. Y equals this is equivalent to y equals that. Remember that equivalent equations correspond to the same graph. So there are potentially different ways of getting the same graph. You can have different looking equations, although they are equivalent, but be careful of the order in which you do things, especially if you start mixing types. This over here did not work. Notice the equation here is not equivalent to what we had from before. Order can matter, especially when you mix different types of transformations. Next up, another way of looking at translations.